Hi students, in previous lecture I discussed about part A and part B preparation for university examination, and in this video lecture I'm going to explain how to prepare part C, which is worth for 13 marks, and that you will be writing 5 such questions, so it is 65 marks. So in each unit there will be certain 3 to 4 possible part C questions. And in certain unit, it may comes around 7 to 8 even, right? Not all the units, some units. So how to learn this and how to, and there are some students are blindly learning the topics. So I didn't say, I mean that you should skip certain part and you must learn only certain concepts. Every concept you have to learn. Every topic, it is really very important. What I mean is, some topics are similar. Yeah, that won't be asked together. For example, if you consider Unit 1, right? Let me consider Unit 1. I take an example and then I'll speak. So I said in Unit 1, we have 3 parts. One is conducting materials, right? Semiconducting material, and optical materials. What are the possible questions in these topics? For example, in conducting materials, we have Fermi function, right? Fermi function can be asked for 13 marks along with the problem. Fermi function inclusive of a problem. Together, it is worth for 13 marks. And density of energy states. Energy states. And even there is a possibility where they can add up all the smaller topics like electrical thermal conductivity together Weidmann-Franz law. If they ask Weidmann-Franz law, you have to write the postulates of classical theory, and that is essential. And you have to write the postulates, advantages, disadvantages, then Weidmann-Franz law. So 3 possible questions in conducting material. And if you consider the semiconducting part, you have intrinsic semiconductor. In intrinsic, there is a derivation, right? It's a charge carrier concentration. Charge carrier concentration. So charge carrier concentration in intrinsic, that is one topic. And another topic what we have is extrinsic. Extrinsic, charge carrier concentration extrinsic, where we have N type separately and we have P type separately. So we have a separate derivation for N type and P type. What else we have is Hall effect. So these are the topics present in semiconducting part. In optical materials, we have certain part, right? So like LED, OLED, and solar cell, which is worth for 13 marks. In addition to some other content, they can ask for some 13 marks. So now imagine if anybody sitting a question paper, they don't cover only conducting materials. 213 marks from conducting material. If they ask, they skip major part of the syllabus, right? In unit 1. And similarly, if they ask 2 questions, 2 derivation part in extrinsic, intrinsic, then they cover only one particular part. So definitely they won't ask. So 11AB, you will be asking either or, right? In either or A side. If one side they ask from conducting, the other part may be semiconducting or optical. So in this manner only it will be asked. Or it may be one part may be semiconducting, the other part may be optical or conducting. Like that, the combination can be any two. One side one question, the other side other question. But mostly if from semiconducting, surely you'll get a question because there are large number of possible 13-mark question. If we take a conducting material, the most probable 13-mark question is density of energy states. The other two are less chance to ask these two questions. And very similarly, even here, this LED, OLED, these are all both for some 8 marks. So in that case, this part also asking these two, right, may be optional. It may be kept optional. Either this can be asked or the other can be asked. But the semiconducting material, mostly you may expect. So one side you can have a semiconducting material. So intrinsic charge carrier concentration, N-type, P-type charge carrier concentration. You learn this and then you go to the other part. Again, I'm saying I'm not asking you to skip any topic. I'm asking you to which one to concentrate first. First, you concentrate on semiconducting material, intrinsic, extrinsic, N-type, P-type, Hall effect. These topics you learn first, which is each and every question is worth for 13 marks in this part. And then you move on to the other, right? Whichever you find it easy, those two topics you take. That means if you find optical material is easy, then you learn LED, OLED, solar cell. And if you find Fermi function and density of energy, this part is easy, you learn conducting material. But any two part you learn, okay, for sure. Yeah. That means again and again I'm saying I don't ask you to skip anything. I want you to learn everything, but first to concentrate on two such part. Okay, this is applicable for each unit. In each and every unit, I'll tell you how to focus. First of all, what are the questions to focus? Then I'll tell you how to prepare for examinations. In unit 2, right? In unit 2. So in unit 2, the dielectric and dielectric magnetic, right? So unit 2 is very simple. Unit 2 is very simple, right? So dielectric and magnetic. So either the 11B question, so not 11, 12A. 12A will be from dielectric and 12B from magnetic. Definitely either from magnetic and dielectric. So if two questions from one part is not possible, only one occasion we had a question, right, where two questions are from dielectric. For example, they asked local field and the dielectric breakdown. In either or they asked. This is only one such question paper I have seen in my career. So otherwise, mostly this one side will be dielectric, the other side will be magnetic. In dielectric, what are the topics to concentrate? So types of polarization. Types of polarization. So this is one very important concept, right? Types of polarization. Second one is local field and Cauchy-Moussatet relation. Third topic is dielectric breakdown. And what else we have? Dielectric loss. And then ferroelectric material. So this is very brief. Okay, even this is related to your syllabus, not completely within your syllabus. So you need not concentrate on this. Yeah. In 12B, it is magnetic materials, right? In under magnetic materials, what are the topics? For example, the first one being types of magnetic materials. Types of magnetic materials. So like diamagnet, paramagnet, ferromagnet, ferrimagnetic materials, and antiferromagnetic materials. These you can briefly discuss. Suppose in types of magnetic materials, if it is asked based on spin, then dia won't come. Diamagnetic is due to orbital motion. So you have to discuss only on para, ferro, antiferro, and ferrimagnetic materials. If it is asked types of magnetic materials based on spin. Sometimes the types of magnetic materials can also be discussed based on soft and hard magnetic material, right? Whether it is used for right, soft and hard magnetic materials. It is based on for what is the application, right? So it can be used for temporary magnets and this can be used for permanent magnets. So, and how easily it can get magnetic. Based on that, it can be classified into soft and hard. So this is one particular topic, which is worth for some 8 marks. So in addition to that, some small 4-mark question or 5-mark question can be asked. And these are all worth for some 13-mark question. In addition to this, we have domain theory. So in domain theory, we have 3 domain theories, right? You have to remember that there are 3 domain theories. The first one is domain theory of ferromagnetism. Domain theory of ferromagnetism. So what you will be discussing in this domain theory of ferromagnetism? So you will be discussing, you will be discussing about how it get magnetized. For example, if you have a closure domain, in a closure domain, if you apply a magnetic field, how it get magnetized, right? This will be discussed. That is the domain theory of ferromagnetism, where the hard domain changes its direction to easy direction, and later, first domain rotation, domain wall motion, domain motion, domain rotation, domain rotation. These two you will discuss, right? So these two you will discuss in this. And then the second domain theory is domain theory, domain theory of hysteresis. Hysteresis, right? So in domain theory of hysteresis, you will be discussing about how the magnetization happens, right? How the hysteresis can be explained based on this domain theory. So in this, initially, when the applied magnetic field is 0, the magnetization induced will be 0. So it is a plot versus B and H, right? So generally the domain theory, so it means generally the hysteresis, it is a plot between BH curve. So here the applied magnetic moment is 0, there is no magnetic moment induced. When it is increased, the initial increase, it is due to a certain point. For example, let me consider this point is A. So until this point, it is due to reversible domain. Reversible domain, right? And later, it is due to irreversible domain. And then the saturated magnetization is achieved due to domain rotation. These points you have to discuss, domain rotation. Am I right? So in domain theory of hysteresis, you have to talk about reversible domain, where you apply the field, remove the field, again it come back to 0. Irreversible domain means the moment won't come back to 0. And domain rotation means the saturated magnetization. That means it won't increase further. It becomes saturated. What is the maximum magnetic field applied to that? Okay. So that is saturated magnetization. And this saturated magnetization happens due to domain rotation. As we discussed in previous case, domain wall movement, domain rotation. Domain wall movement will take place from this position to this position. Domain rotation takes place in this position. So you have to discuss the hysteresis relevant to domain theory. And then the origin of domain theory. Origin of domain theory. We speak about domain theory. So how the domain theory is originated, how the domains are originated within a material. The domain are originated due to four energies, right? There are four different energies. In order to minimize these energies, magnetostatic energy, exchange energy, anisotropic energy, and then the final is magnetostrictive energy. Magnetostrictive energy. In certain textbook, even they give domain wall energy, but that comes under magnetostrictive energy. Okay, so, sorry, magnetostatic energy. Uh, so it is not mandatory that should be discussed separately, but even if you discuss that separately, that is not a wrong concept, right? So here, these four energies, in order to minimize these four energies, whenever they ask about origin of domain theory, you have to discuss these energy. What are these energies? And how to in order to minimize, in order to being a minimum value, domains are found within the solid, because if the domains is not formed, and if all the atomic dipoles are oriented in a particular direction, then all these energies are maximum, which is the unstable condition. No material in this world will be in the unstable condition for a longer duration. It try to become stable. In order to become stable, these energies are minimized. So these are the topics that you have to learn in magnetic material. So as I discussed, either the question will be from dielectric or magnetic. The next unit is unit 3. In unit 3, nanomaterials. In nanomaterials, we can split into three parts. One is the synthesis part, synthesis, and second is properties, and third is application. It is better to focus on any two particularly. Okay, but the synthesis, most of the cases they won't skip question from synthesis, because many questions are available in synthesis. For example, sol gel method. Second is co-precipitation. Third is ultrasonification. And fourth one is ball milling. So like that, we have many methods of synthesis. So mostly they won't skip synthesis. In properties, all the properties together, some electrical property, optical, magnetic, uh, chemical property, and catalytic, antimicrobial antimicrobial resistance. Okay, so these are some of the properties which I listed here. There are many other properties also there. So you have to discuss all these properties. And applications, the two major applications focused, as I said earlier. The first application is related to agriculture. And second application is related to medicine. So applications based on agriculture and medicine is very, very important. So these are the topics that it is there in uh, Unit 3, nanomaterials. So focus on any two. Either you learn synthesis and properties first, or synthesis and application. So synthesis, you keep it as a common parameter. The either properties or application. And even I never say you can skip this. First concentrate on any two topics. Then you can go to the other topics if you have very less time. Okay, so all these preparation techniques have been listed here in order to Make it simple, and if you are at the edge, you couldn't spare more time, then how to make it easy? In that manner only I'm saying these two you can focus, and this can be focused later on like that. Okay. The next unit is unit 4. Unit 4. Right? Unit 4 is characterization of materials. Characterization of materials. So in characterization of materials, what are the questions available? The available questions is DLS, TGA, DSC, HPLC, GCMS, NMR, scometry, rheometry. Of course, the AI integration is there. Even the AI integration is there in other unit. AI integration in characterization. Definitely, in either or, they never ask TGA and DSC. These two cannot be asked together. In A, P, like that they won't ask. Similarly, these two will not be asked together as A, B, this is B, not possible. Either this question, one question, this or this, or this, or this, like that it will be focused in this manner. So what you can do is you can skip some part initially, you focus on the other. For example, DLS you learn, TGA, DSC you learn if it is easy, or you can skip as of now this and you can focus on this GCMS HPLC. And NMR, of course, you have to learn. You have to learn. And these two topics are not very much worth for 13. So you can give less importance these two topics. Again and again, I'm saying less importance. I never say you should not give importance to that. It is less important. And AI integration, of course, this is also a possible question. But as of now, first focus on this, right? The DLS, TGA, DSC along with NMR, or DLS, HPLC, GCMS along with NMR. Minimum 4 questions you have to learn to answer one. Okay, so we cannot simplify further. And unit 5. So what is difficult in these units are each and every topic is separate topic. I have already mentioned this. So that is the difficulty why we couldn't say exactly this particular part can be read or. So at least in magnetic and dielectric we can segregate magnetic or dielectric. We cannot segregate here. Every single topic is unique. Nothing can be come under one roof. For example, dielectric local field is there, types of polarization there, dielectric breakdown, all these will come under dielectric. But here it is not like that. So metallic glasses. But however, we can learn the topics in this manner. Metallic glasses, shape memory alloy, shape memory alloy. So this is one important topic, and then right, and then you can talk about sensor. Sensor. In sensor we have biosensor, chemical sensor. So either of this cannot be asked. Any one will be asked. And what else topic we have? Spark fluid. Electrorheological and magnetorheological. Electrorheological and magnetorheological. Either electrorheological can be asked or magnetorheological can be asked. Any one can be asked. Either in either or these two cannot be asked, right? And then what else topic we have? We have, of course, we have AI integration and biomaterials. Under biomaterials, we have PMMA, hydroxy, apatite. And third topic is, just a minute. Sorry for the interruption. So here, these are the topics which is present in this unit, right? So PMMA, hydroxyapatite and silicone. Silicone, these are the topics which is there. In addition to that, AI integration. AI integration is there. So question can even be asked on this. And there are certain, right? So here how to learn. All are separate topics, how to learn. What to learn, which question must be given more importance. There's more importance truly here can be given only based on the number of times the question have been previously asked. So these two questions which is previously asked and this question sensor have been previously asked and smart fluid also previously asked, but the chances, right? The chances can be the more number of times this has been asked many occasion, and this has been asked less than that. And the next importance can be given to this. Next importance can be given to this. Next to this, and next to this. In this order, you go. We can tell only the order. We cannot skip any topic. We can learn in this manner. No other option in this unit, especially.